Okay, so I made like this little diagram. I will first kind of explain it here, and then I'll go on to the other side. Okay, so basically, the way I like to think about it is there's three categories. You have your warm receptors. This basically takes in the temperature from the outside. And then you have a warm neuron and you have an insensitive neuron. And then number 3 is you have your effector neurons, and these are the ones that actually produce whatever effect. So basically how this diagram basically work is for one guy to do like firing, like here, right? It needs to be turned on by a green. If it's not turned on by a green, he will literally just be quiet and not do any firing, okay? So let me just write that down. Needs to be turned on to do next steps, or like firing. I'll just say firing. Okay, and so now we can kind of follow the pathway. So you have a warm receptor or a cold receptor. If the warm receptor will turn a positive, which is like a turn on message to the warm neuron. The cold receptor will turn on a negative or inhibiting or a turn off to the warm neuron. And basically whoever wins, then we can then decide whether the warm neuron will be turned on or off. So next to the warm neuron, we have this warm neuron, but we have nothing such as a cold neuron, like it's just not there. But instead we have something called an insensitive neuron. And what the insensitive neuron is basically doing is this guy, he doesn't need to be turned on by anything. Like he doesn't need any input to turn him on. He's always going to be firing. So let me just write. He's always going to be firing. Always firing at a constant rate. And so what that means is basically this insensitive neuron is going to be firing at a certain like rate to this guy and also to this guy. And that means he will always be turning on the warm efferent neuron. He will always be turning on the cold efferent neuron, right? But the question is, if this guy is always firing and turning off the warm efferent neuron, when will this efferent neuron turn off? So this efferent neuron will turn off when this warm neuron is turned on by this guy. And then when this guy is turned on, his signal will overpower that of the insensitive neuron. And so the way I like to think about it is we have two efferent neurons, and it's an or situation, meaning one has to win. And depending on whether the warm neuron or the I neuron is stronger, one of them will win. So after that, once one of them has win, the effector is going to think, like, I like to think warm efferent neuron means, oh, I'm hot, so I want to cool down, so we need heat loss. And that will be just memorize vasodilation and sweating. On the other hand, you have the cold efferent neuron, which is going to be like, I'm cold, and so you want to produce heat instead. And this is memorize vasoconstriction, shivering, brown fat adipose cells. So I would just recommend maybe you can like take a picture of this and then just like recite this whole pathway to yourself, and then we can maybe ask each other questions if you'd like. Okay, and now just to connect it to this chart so you can kind of understand what's going on here. So remember we said the warm receptor, cold receptor, it's literally the same thing right here. And cutaneous because it's specifically on the skin. And this guy will basically turn off. So SP here is setting point. I don't know what that means, but I just think it's like another wire connecting to these guys. So cold receptor will turn off, the negative inhibiting effect, positive turn on. And then that will here we can see our warm neurons and our insensitive neuron here. And now this warm neuron, so when this if this SP guy is turned on, if it has a positive effect, it will go here, turn the warm neuron on. If the warm neuron is turned on, it will win over our insensitive neuron here and do a positive effect. It will turn on our warm efferent neuron, and it will also inhibit our cold efferent neuron because, it's like, hey, I'm warm. I want like the warm efferent neuron to turn on, and I don't want the cold guy to turn on, right? And then we have this insensitive neuron here, which is always just firing at a constant rate. And so basically, if this warm neuron is never turned on, this insensitive neuron is just basically going to win. And so if it wins, it will just inhibit the warm efferent neuron, and instead the cold efferent neuron will turn on, and the cold efferent neuron will win. And then, the cold is like, hey, I'm cold, so it'll produce heat. Or the warm afferent neuron will be like, hey, I'm hot, so I want to lose my heat. And that kind of sums up everything. And so like these graphs over here are just basically describing like, honestly, I don't know, just, yeah. I think it's like, so you can see like the green here is firing at like one rate, right? Like a constant rate. And this red, once it like exceeds, the red here is like the warm neuron. So like once it exceeds the insensitive neuron's rate, then it will start firing. Let me know if you have any questions.